Section 9.4 Phasor relationships for circuit elements. From now, we're going to try use Phasor to solve the sinusoid circuit. First of all, let's look at the resistor. Suppose there is a resistor. The voltage across it is V, and the current through it is I. According to Ohm's law, we can get the relationship in time domain V equals I multiplied by R. And then we transform both current and voltage into phasors. We get phasor V equals phasor I multiplied by R. If we draw the phasors in this graph, and we can find the phasor V and phasor I are in phase. And phasor V equals R multiplied by Im angle phi, and phasor I equals Im angle phi. So the phasors are also obey Ohm's law, which means phasor V equals R multiplied by I. For the inductor, if we transform both the voltage and the current inside the phasors, and we get the relationship like this, V equals j omega L multiplied by I. If we draw both of the phasors inside one graph, and we will get a phasor graph like this, we can find the phasor V is leading I by 90 degrees. For the capacitor, if we transform both voltage and current inside the phasors, and we will get the relationship between phasor I and phasor V. I equals j omega C multiplied by V. So we can draw both of the phasors inside the graph, and we will find the phasor I is leading V by 90 degrees. So we can rewrite the relationship like this. V equals I over j omega C. And now we can put the relationship between the voltage and the current of resistor, inductor, and capacitor together. And we will find the difference. And we will find for the resistor, V and I are in phase. However, for the inductor, the voltage V is leading the current I by 90 degrees. And on the other hand, for the capacitor, the current I is leading the voltage V by 90 degrees. And we can find the comparison of the relationship between V and I for resistor, inductor, and capacitor inside this table. And we can find the relationships in time domain and in frequency domain as well. And we can find the relationships in frequency domain are quite similar, which means V equals something multiplied by I. And they are very similar to the Ohm's law. Now let's look at the example. We know the voltage, and we know this voltage is applied to an inductor. We need to find the steady state current through the inductor. So we should know the relationship between the V and I in phasors. V equals j omega L I. And then we transform the sinusoid into the phasor, and we get V equals 12 angle 45 volts. Hence, we can calculate the current I equals V over j omega L, where omega equals 60 radians per second. And we put the numbers inside, we get I equals 2 angle minus 45 amperes. And then we convert the phasor I into the time domain, and we get IT equals 2 multiplied by cosine 60 t minus 45 degree amperes. This is the end of this section.